Welcome friends. This is the second part of my breadboard computer, 8-bit breadboard computer. So last time I just installed the program counter and this arithmetic logic unit, RAM, but not control signals or control lines for this computer. So it will be the dishonesty if I will not take the name of the famous YouTuber Mr. Bennett. The program counter. This is the A register. This is the B register out. That is the sum. So 74 LS 21. So 4 input AND gate used for this NOR gate IC. Zero 2 is the NOR gate IC, and this C74 LS 21, and this is 173 for flag register. This is the AND gate. Okay, this is the RAM. Mm, 74 157, and this is 273. This is also AND gate IC, and this is 57, 74 less 157. This is the AND gate IC. This is 273 for instruction register. It's a buffer 245. These are the deep switches for programming the RAM. Manage the address manually. These are the deep switches. It's memory address register. AND gate 7408. This is 161, 74, and 138. This is, and these are the 2816 CP eeprom ICs, and all are these control signals. This is the NOT gate 7404. So see, control signals are there. See, these are the control signals. So ALU result is okay. The 7 plus 7 is 14, and this is a clock. 556. So reset line, you can see this black color reset line to this X161 reset line. So 7 number of output of this, which is inverted, so it requires the low level signal, so it reset immediately when it reached to the 7th number. And this is the most important, is the bus. So the flags indicator 0 and carry. So this is the 8-bit program counter. Just get an idea. This is the bus line. This is memory address register output. You can see over here. This is the memory address register 8-bit. Okay, these are the deep switches to program the RAM manually and set address with the help of these deep switches. And these are the 74LS157 2-line multiplexer, that is, we can select one between 2 line, and this is the arithmetic logic unit. And now I install these control lines. So what I am facing problems with this breadboard computer, we'll see it in a minute. See, this is the B register, this is the A register, this is the output for the A register output unit. It means we can see what inside the A register, what inside the B register, and what is the output of this arithmetic logic unit over here. I am out, and as well as we can easily see what is on the bus with the help of these LEDs. 74 LS273, not this, this is 273, which has only a clock line, unlike this 173 which used for the flag register. So 273 has only one line, so we connected it to the AND gate. This is the AND gate, you can see, and one end of this input is connected to the input of one A input of the AND gate, you can say, and the B of this AND gate is connected to the clock line. So when both lines are high, we can store data into this register. So see what problems I am facing first. So most basic problem I am facing right now, you can see. So this is the 556 timer, dual timer IC. So both side has a timer circuit. So this is the timer 1, you can see, this is the timer 2. So one side is a monostable and other side is a stable. So this is you can say the trigger. We can trigger the clock whenever we want. So this is that monostable, this is the stable. So let's reset this all registers. we reset that. Then this memory address register, this is the memory address register, we reset that. This is the instruction register. No, this is the instruction register, so we reset it. Okay, this is the output register, we also reset that. B, these are the flag indicators, LED. See, this is 2816 CPI. See, this is the xicor 2816 CP. These both ICs are eeprom ICs, electrical erasable read-only memory. So electrical erasable read-only memory integrated circuits. So these are the 10 address lines, 0 to A10, A0 to A10, and 8 input output lines, that is data input and output lines. So both are giving 16 input out lines. So we make the common address line, we make the common. So we connected first 7 addresses and then we get the output for individual 8 input output line. So this first 8 input output 3, 3, 6 to 8 for this, and the remaining 8s for this. So we'll see that how we program it and what is the technique to program. But the problem I am encountered with these control lines, so they are working properly when I test them, but when I connected to these NOT gates 7404, they are not working properly. So you can see these two outputs are high, that is input output lines are high. These two control signals are high. First is counter out, so counter will get out, and second one is memory address register in, that is memory address register. But in fact these are not giving the expected signal. And why it is happening? Because we are getting the low voltage output from this eeprom. This is the counter out connection. So counter out is active low, so we get it through the NOT gate. So that pin is always high. Now it is high, so through this NOT gate that pin is now low, but it is not the case. So you can see this is the ground connected, and when I am connecting the third number pin, this pin, so it is high. And also see, this is also high. So input and output are both high, because input is giving 3 volt and 3 volt is not enough to activate this NOT gate. The voltage I check all the way is okay for this eeprom, that is around 5 volt, 4.5 to 5 volt. But output of this EEPROM is not as expected, as we want 4 volt or above 3.5 volt. We are not getting that voltage, and so our control lines are not working properly. So result is very awkward or very abnormal we are getting. So when I program this RAM, put little code inside this RAM, that is not giving expected result. So what is happening actually, see address is 0. This is right now all that modules reset and are nothing into these registers. So when I am pushing this trigger, clock trigger, see, this is the unexpected values we are getting. EEPROM showing the correct programming, which is we did for this computer. So this is the 3 and this is the 4. So 3 0. So 3 0. So this is the 3 and this is the 0, and this is the 4 and this is 0. That is okay. Same value. See, this 7. Where from this 7 is coming, I don't know. This is the steps. These are the, we are getting the steps from this 13874 LS138, and we reset this. We can see the reset after 7th clock. 5, 6, 7. So with the help of this is actually 74 LS138, and this is 74 LS163 4-bit counter IC, and this is the decoder IC, demultiplexer IC. So we can reset these steps when we reach to the number 7. So now 1 B register, so output is 0 plus 1 1. So this ALU is working okay, but just because of this control line, so control line we are not getting the proper result. So we are facing a problem. Another problem I am facing right now, that is what, when, see, this is 157 and this is the select line for 157. So I want to program this RAM. So I just, when I want to program this RAM, I just want to make this pin low select line. Okay, and I entered into the programming. Also for this we should select 0, so that now 0 address, and we will program what should on the 0. But if I program this 3 number, that is the third LED, that is, you can say 32. So this bit will not program inside this RAM. You can see right now I just give a pulse for write enable, write this data inside the RAM. So now we'll make low and check for this thing, nothing. But same thing for any other bit will work. So now this is the 1 and I want to program 1 into this RAM, it will program. Okay, now it is programmed. So let's check whether it is programmed or not. See, it is programmed. This is the output enable. So 2 lines are there. So one from the control signals and another from directly. So when we are selecting, that is making this pin low, we entered into the programming, manual programming mode, and we can program. But you see the problem, that third, that most significant bit, this bit number 5, 0 1 2 3 4 5 6, bit number 5 is not working. And I checked the lines, all the lines, that I found this RAM is responsible for this thing, not other things. So we can program anything, any value we want. You can see this value also at the address, suppose 2, address 2, we can program this value, but this bit will not program, only this bit we can see. So we just program, and now we can see what is on this address. The address 2 will see only one thing. And now if we'll want to program this and this, that will program. See, so we just program inside this and make this pin low, and now you can see on the address 2 this thing. See, problem, I check all connections, the problem inside this RAM. So we will replace that RAM or do something else. So two problems are there. One is from the control line, that it not getting the voltage required for this NOT gate, and this is 3 volt around, so it is not enough for that. And the other problem is here in entire computers, that we cannot connect directly to this 74 series IC. So if we do that, these start working improperly. So this ALU is working properly. 7 plus 7 is 14. 7 plus 7. So it is working, but just because these control lines not giving the proper output voltage, we cannot convert these signals high to low. Okay, this is the Bayonetta inspired 8-bit breadboard computer, and the Bayonetta is very famous YouTuber, uploading his video related to the electronic or computer especially. So this is actually, I got the problem for this wiring. So this yellow color wiring is not giving the proper result just because of the loose connection or whatever. So I stuck into the problem, or I face unwanted result just because of this loose wire. So I realized the thing, and I find out the solution for that. So I just, this wire, I actually, you can see, bend on some position, and then I insert it into the breadboard so that it will make the contact with the terminals properly. Okay, no problem. Now I reset all this computer, and I will explain what is going on here. So I am resetting this all memory address register, program counter, so one by one. So this is the, you can see, okay, this is the program counter, I reset it. This is the memory address register, I reset this. This is the instruction register, I reset this. This is the B register, B register. This is what the A register, B register. So that is the unwanted data. And these are the control lines. Okay, no problem. So these are the selector integrated circuit, that is IC 157, 74 157, these two and these two. So all the rest of the things you know what is that. Okay, these are the AND gates, this is the NOT gate, this is the AND gate, these two also the NOT gate ICs, 7404 and 7408 is the AND gate. Okay, this is not I'm right now using because I'm not getting the proper result, and so I'm find out where is the problem. So let's first install or program one only instruction, that is the load A. So